was a very conservative design, designed back in the late 70s, early 80s, I guess. It was still flying and performing quite well, with minor aeroelasticity concerns because of the mass having changed, but it wasn't nothing that the pilots couldn't deal with. So the course is about taking the loads from somewhere, and for homework I will be giving you the loads most of the time, and the material properties, and then coming up with a structural configuration, which at the beginning can be anything based on previous experience, luck, your own intuition, or some intelligent way that you may have to come up with an initial configuration, such as the stacking sequence of a laminate, for example. Then you analyze this, and you need to make sure that it meets loads without failure, static and fatigue, and we won't be talking about fatigue, which is another very complex, interesting, and challenging problem in composites. And you try to minimize weight. Hopefully, you are also cost conscientious, if not explicitly trying to minimize cost also. And depending on the application, you may want to have additional attributes such as frequency placement, especially for helicopters, radar signature if it's on the military side. But very rarely your first configuration is the one that is your final one, and you need to iterate as you go through the analysis and finding either the structure is failing or it's not performing as you have wanted, and so on. And it's these iterations and automating or speeding up these iterations that's the biggest, most interesting aspect in all this. This one is just the same thing in block diagram form, so I'm not going to talk too much about it. There's a preliminary design, which can be a guess or a previous experience. Then you come up with a configuration, and around this configuration,